Hello and welcome to the lecture session on partial differential equation. Today's topic, we are going to do the variables. Solution of the homogeneous equation involving the derivative with respect to one independent variable only. So this is the today's topic. So solution of homogeneous equation involving derivative with respect to only one variable, one independent variable only, is obtained by first treating the PDE as ordinary differential equation and finding the solution of the ordinary differential equation. The arbitrary constants in the solution of the ODE or ordinary differential equation are replaced by arbitrary functions of other independent variable, giving a solution of the partial differential equation. So let's see the problems. Solve dou square z by dou x square minus z equals to 0 given z is cos y and dou z by dou x is sin y when x is equal to 0. Given dou square z by dou x square minus z equals to 0, call this as 1. Assuming 1 is an ordinary differential equation, that is d square z by dx square minus z equals to 0. And we already explained in the second module that how to solve the ordinary differential equation with the second order. So how it has to be done is the auxiliary equation first we will find out, that is d square minus 1 of z is equals to 0. We get m square minus 1 is 0 and m is equals to plus or minus 1 when it is a real and distinct roots. So we get c1 e power x plus c2 e power minus x is the solution of the ODE. The solution of PDE is given by z is equals to, this c1 is replaced with f of y and c2 is replaced with g of y into e power minus x. Now differentiate this with respect to x, treating y as a constant. We know that dou z by dou x is f of y e power x minus g of y e power minus x, because it is differentiated with respect to x, treating y as a constant. Therefore f of y and g of y will be taken as a constant. Now put x is 0 in the 2 and 3, we get second equation, that is z, which was cos y is equal to f of y plus g of y, and sin y, because dou z by dou x is a sin y, which is equals to f of y minus g of y. Solving this, 2f of y is equal to cos y, that is f of y is equal to cos y plus sin y and g of y is equal to cos y minus sin y by 2. And this implies z is equals to e power x by 2 times of cos y plus sin y and e power minus x by 2 times of cos y minus sin y. Now among this one and this one, we can take the common term as a cos y. When we take cos y to common, e power x by 2 plus e power minus x by 2, which will get it. And similarly sin y, if we take common, sin y is multiplied with e power x by 2 minus e power minus x by 2, and we know that e power x by plus e power minus x by 2 can be treated as cos hx, and e power x minus e power minus x by 2 can be treated as sin hx. So this is going to be the required solution. Next, dou square z by dou y square minus 4 dou z by dou y plus 4z is equals to 0, and given that dou z, z is equals to 0 and dou z by dou y is e power x when y is 0. So again this one we will consider it as an ordinary differential equation, that is d square z by dy square minus 4 dz by dy plus 4z, or d square minus 4d plus 4 of z is equals to 0, which can be written as m square minus 4m plus 4 is equals to 0, which gives us m is equals to 2 comma 2. And the solution, it is a repeated root, therefore the solution of ODE is given by z is equals to c1 plus c2y of e power 2y, where c1 and c2 should be replaced with f of y and another function. So f of x into e power 2y plus y g of x into e power 2y. Differentiate the equation 2 with respect to y, treating the x as a constant. Then we get 2 e power 2y plus 2 e power 2y g of x y plus 2y, because here in the second one y and e power 2y both are functions, only g of x is a constant. Therefore y into e power 2y means we have to differentiate by product rule, UV method. Therefore g of x, which is a constant, 2 into e power 2xy plus e power 2y into derivative of y, that is 1. This is what on differentiation we get it. Now let us put y is equals to 0 in the second equation. This is the second equation. Y is equals to 0 if we are putting and we have z is equals to 0. E power 2y will be 0. Since y is a 0 here, this term will be 0 totally. Therefore we get f of x is 0. This is what we get it. And in the third equation also we will consider, that is dou z by dou y. It is given in the initial condition, you can refer here. Dou z by dou y is equals to e power x when y is equals to 0. Let us use this one. So dou z by dou y is 0, e power x. When we substitute that, it is equals to 2 into f of x. Since y is 0, e power 2y will be 1 and e power 0 again into g of x, and the middle term again it will become 0 because y is multiplied. And therefore f of x is 0 we have already obtained, and we get g of x is equals to e power x. We have got f of x is 0 and g of x is e power x. This can be substituted in the second equation. So when we substitute in the second equation, z dash is equals to this one, or z is equals to y e power x plus 2y, or z is equals to y into e power x into e power 2y, that is given by e power x plus 2y. This is the required solution. Next, let's solve the another equation. Dou cube y by dou t cube plus 4 dou u by dou t is equals to 0, given u is 0, dou u by dou t is 0. Dou square u by dou t square is 4 when t is equals to 0. Here you can observe the three terms are given, or the three conditions are given, whereas in the previous one only the two conditions were given, because in this we are having cubic equation, so we will be getting the three constants, because the three roots we will get it, and thereby three constants we get it, and that three constants will be replaced with three functions. And in order to solve three constants, we need to require the three equations. Therefore this will be three equations: dou u by dou t, dou square u by dou t square. This we will be getting as three separate equations. Now let's assume the equation, and this is an ordinary differential equation. We get d cube y by dt cube plus 4 du by dt is equals to 0. So d cube plus 4d of u is 0, or m cube plus 4m is equals to 0, and you can take m common. Let us explain here this part. When m is taken common, we will be getting m square plus 4 is equals to 0. Therefore m is equals to 0 and m is equals to m square is equals to 4. M square is equals to minus 4, we get it, and when we take the root of it, we will be getting it as plus or minus 2i. Hope it's clear. Next, here we are getting the solution of ODA is given by C1, because this is e power 0 means 1. C1 plus C2 cos 2t plus C3 sin 2t, and the solution of the PDE is given by replacing C1 with f of x, C2 with the g of x, and C3 with another function, that is h of x. So we are getting f of x plus g of x cos 2t plus h of x sin 2t. This is what we will be getting it. Now differentiate this with respect to t, treating x as a constant. Then we get dou u by dou t is equals to minus treating x as constant, so f of x will become 0 because no other term is multiplied here, and minus g of x into sin 2t into 2. because sine to cos 2t is differentiated and it will be minus 2 sine 2t into g of x plus twice of h of x into cos 2t. This is what we get it. Now let us differentiate the equation 3 with respect to t partially. Because we have the three conditions. One is u, another one is dou u by dou t, another one is dou 2 u by dou t2. So let us differentiate this again with respect to t partially. Then what we will be getting is minus 4 times of g of x is a constant, cos 2t minus 4h into sin 2t. This is what we get it. So this we will call it as equation number 4, and we will substitute the constants, substitute the conditions. Let us once again observe the conditions what they have given. Here u is 0, dou u by dou t is 0, dou square u by dou t square is 4. So we have got u as this one, dou u by dou t as this one, and dou square u by dou t square is this one. So this is 4, here it is 0, here it is 0. Let us substitute and then see. So put t is equals to 0 in the 2, 3 and then 4. We get it as first equation, that is 0 is equals to f of x plus g of x. And the third equation 0 is equals to 2 times of h of x. And 4 is equals to minus 4 of g of x. Hope it's clear. And h of x will be 0 because of the third equation. And g of x will be minus 1. So g of x is minus 1 means f of x is plus 1. Thereby we are getting all the three equations, all the three functions f of x, g of x and then the h of x. So which implies the second equation we will replace in the value of f, g and h. Then we get 1 minus of cos 2t. Or we can also write it as 2 sine square t. This is the required solution. Thank you.